next speaker, continuing with our resilience theme, is Victor Rodríguez. He's a professional services veterinarian in the Spanish team for Boehringer Ingelheim. He has a broad experience of swine. He's a veterinarian with broad experience in swine medicine, has worked for a genetic company, breeding company, and production systems, and has been with BI around 6 years, because he started at the same time as me. And I'm very happy to have him here present some really new information about how we can use some of the tools that we're developing to understand risky behavior and risky areas on farm. So, Victor, the floor is yours.
Thank you, Oliver, for the presentation. Okay, first of all, let me play a video to introduce what's P-Track.
Boehringer Ingelheim presents P-Track, the first on-farm tool developed in collaboration with Accent Systems that will allow farmers to trace risks associated with pathogen-carrying agents like people or objects. When planning a control plan for a disease like PRRS, it is essential to follow a systematic approach like the 5-step process. The first and second steps aim at setting the goals and expectations and determine the current status of the farm. On the third step, we must identify the constraints, namely the biosecurity and management risks that we have in our farm or system. Then, we can propose the solutions, and finally, in step 5, we implement them and monitor the results. Some risks that complicate disease control are associated with pathogen-carrying agents, like objects, people, and animals, and they normally remain undetected. Now, Boehringer Ingelheim introduces P-Track, the ultimate tool to monitor those risks with the beacon technology of Accent Systems. P-Track is a pathogen tracing kit that allows to trace and monitor multiple risks associated with pathogen-carrying agents in the farms: objects, farm staff, visitors, or fomites. Using P-Track, veterinarians and farmers can measure and analyze in real time risky events related with movements, for example, employees or visitors moving from a quarantine barn into the nursery, or sharing certain tools or objects in different barns, like fattening and farrowing. Also, P-Track can measure positioning inside or outside buildings, and with this property, the areas of the farm associated with more risky events can be easily identified. For example, stepping outside onto the dirty side of the loading dock, which has been linked with new outbreaks of disease, can be detected faster and corrected earlier. PRRS is a complex disease that requires a systematic approach to control using all the best available tools. Boehringer Ingelheim continues to work on solutions that benefit the swine industry by focusing on all aspects of prevention. Now, with P-Track, it will be faster and easier to improve the implementation of biosecurity measures. Boehringer Ingelheim is committed to continue developing and offering innovative solutions and tools to help control PRRS and other challenging swine diseases. Prevention works, shaping the future of swine health.
Okay, as you know, we need a systematical approach to control PRRS because it's a complex disease. And when we have a look to the picture, we see that the biggest ball is the third step. And this step, understand current constraints, talk us about biosecurity and management. And in this context is where P-Track can help us to understand what's going on in the farm. When we talk with producers, all of them understand that they have to prevent the entrance of new agents, new virus or new bacteria in the farm, and some farms are like a fortress. But what happens if we have the virus or the bacteria into the farm? We have to prevent the spread in all the farm. When we have a look to combat that PHO present to us, we can see that a lot of farms have high internal risks. Even farms with low external risk can have high internal risks. And for us, it's very important, the carrying agents. Carrying agents could be pigs themselves, but could be the workers and all the items that they have in the farm. For example, what happens if this worker vaccines all the piglets in this pen, and then he goes directly to the farrowing barn? So if we have here E. coli or Pierce virus, he can carry the bacteria or the virus to the farrowing barn. And what happens if one worker loads a truck and he is in contact with the truck, with the truck driver, and he goes directly to the farm again? It's a problem. And worse the situation if he put the dead animals in the box and he goes directly to the farm. I'm going we started with pit track in 5 farms, 2 in the north of Spain from the same production system, and another 3 in the central part of Spain, 2 here of the same production system. All of these farms are Pierce positive and unstable. We find PCR positive in all of the farms. We do 5-step process in all the farms. And you can see here that the type of the farm is different. We have 2 farms, farrow to wind, 2 farrow to feeder, and 1 farrow to finish, and the size is different between farms. We did combat in these farms, and you can see here that we have 1 farm with more internal risks, and the risk of management is different between farms, but this one was the worst in management risk. And we started to take samples. We started taking samples. Green is negative, PCR negative. Red is positive. And the another colors are vaccine strains, okay? When we started in this farm, in the nursery, we collected 10 blood samples every month, and from the start of the program, we found all the months positive piglets. In the due-to-wing piglets, when we started, we found negative piglets, but in 1 month, we found 1 positive. After 1 year and a half, we decided to depopulate the farm, the nursery, except the gills. The gills, we keep the gills in the farm. And after that, we found again the virus in the nursery. For sure, it was a mistake to keep the gills in the farm. But after that, we found the virus in the due-to-wing piglets. So the virus went from the nursery to the farrowing barn. Okay, this is another example. This is a farrow-to-finish farm in Spain. And when we started with the program, we found the virus in the fattening. After that, it moved to the nursery, and we depopulate the nursery and the fattening, and we started collecting PCR negative. But we had a lateral entrance of virus. After 3 months, the virus went to the farrowing barn. So who is carrying the virus from one part of the farm to another part of the farm? So as Deming said, you can't manage what you don't measure. And PTRAC helped us to measure what is going on in the farm. For example, what happens when the workers came and park the car and go to the farm? They go to the dressing room or not? They go directly to the the station or to the farrowing, or they go from the farrowing to the nursery? We need to know what is happening in the farm. And we developed with Accent the tool. And the tool is made with this device. This is a beacon. It's a Bluetooth emission, and the signal is received by a mobile, a smartphone, or another device. And when the worker is close to the beacon, it's detected and the system knows where the worker is. If we put several beacons, we can triangle where is the worker and who is him moving in the farm. And then the smartphone sends all the data to the cloud, and we can analyze all the data in real time. What we do is to define the risky areas in the farm. So, for example, if we found PCR positive in the nursery, for us, this is a risky area. The load area is another risky area, but we can change the risky areas. For example, if the farm is free and I have entrance of virus, I can change my risky areas. Okay? Or if I get rid of the virus, I can change again the risky areas. This is one of the farms, one of the examples that we are doing in Spain. In this farm, here we have the GDU. These 3 units are gestation. Here is the farrowing, and here the nursery. Here you can see the load area. Here they put the dead animals, and here is the dressing room. Well, what the system tells us is this dashboard, and here you can see all the movements made by people in the farm. It gives us the percentage of correct movements and incorrect movements. We call incorrect movements movement from a risky area to a less risk area. We can see it in the time, a month, a week, and we can know what is happening in the weekend or whatever. And it sends us several alarms. Here you can see all the movements made by people in the farm, and we can filter and see just the risky movements, or see what movement you have between each part of the farm, each unit. Here you can see the numbers. These numbers are the number of movements that people do between different units. Here, for example, you can see just the high risk and very high risk movements. For example, you can see that from the dead animals, they go everywhere. And from the low-tower area, they go everywhere too. Excuse me. Okay, here you can see the evolution in the time, and you can filter. You can filter depending of the areas, depending of the time, depending of the worker, whatever you want, depending on the zone. And here you see all the movements. The circle, the size of the circle depends on the number of movements, and the color depends on the risk. For example, risky movements are red. You can see here that from the loading out area, they go almost everywhere. From the dead animals, they go everywhere. But for us, what is important in this farm is that from the nursery, where we found PCR positive piglets, they go a lot of times to the farrowing barn. So this movement of the virus is related to this. In my mind, it makes sense. That could be that movement, the responsible of having the virus now in the farrowing. So this let us train the people, keep on training the people, and tell what they are doing in the farm and how they can reduce the risk. Of course, risk zero doesn't exist, but you can manage the risk.
Creo que esta sistema es muy buena para controlar el flujo de personal en la granja.
A mí, como encargado de la granja de madres, creo que es fundamental tener separadas las distintas fases, de modo que este sistema me permite de forma novedosa controlar los movimientos de mi personal en la granja. Así puedo ver cómo se mueven entre partos, gestaciones y cuarentena y analizar las consecuencias de estos flujos.
Creo que instaurar este tipo de sistemas en granjas para el control de PIR nos ayudará a los técnicos de producción y a los veterinarios a poder instaurar un flujo de personal coherente con las ideas y las técnicas que queremos llevar a cabo dentro de esa explotación. De este modo evitaremos recirculaciones del virus en zonas donde no queramos que exista esa posibilidad, cortando flujos de personal entre parideras y zonas de gestación o entre zonas de gestación, parideras y destetes. De este modo conseguiremos mantener más estable la granja y conseguiremos una producción final más exitosa.
So all producers, owners, and veterinarians understand the system and understand that PITRA can help us to improve the results of the farms. The next steps developing the tool is put beacons in different items in the farm to understand if they are moving the pairs, and the possibility of having alarms in the mobile. So when a worker is going to do incorrect movement, the mobile sends him an alarm, and he can do another movement. So, in conclusion, we need to minimize the agent disseminations inside the farms. We can analyze and manage the staff movements in real time. It's a dynamic tool because we can change the risky areas, and it let us keep on training the staff. So may the pork be with you, and thank you very much for your attention.